The large ball of fire thousands of miles away from us is the brightest object in our solar system, as well as the biggest. If Jupiter was the size of a basketball, then the Earth would look like a tiny little grape. But the Sun makes even Jupiter look like a joke. That big burning ball in the sky is made up of hydrogen and helium, and is 864,000 miles in diameter, making it more than 100 times wider than our little blue planet. It's 10,000 degrees Fahrenheit just on the surface, and 27 million degrees at the core. The Moon, on the other hand, is a little easier to grasp at around 2,160 miles in diameter, which is only less than a third of Earth. It might seem pretty big floating in the sky, but that's because it's the closest object to us. But what if the tables, or in this case, celestial bodies, have turned, and the Moon suddenly became brighter than the Sun? Let's explore several scenarios. Scenario 1. If the Moon becomes brighter than the Sun, the nights will be brighter than days. It means your sleep cycle will be disrupted. All nocturnal animals will be utterly confused. When is it time to go out and eat now? In the extreme north and south poles, the nights and days are for months on end. So people living in the area already have an idea of what it's like to sleep at 11 p.m. with the sun shining brightly above them. For the rest of us, it won't be easy. Let's say you're out camping and prepare an awesome meal and gear up for the dark nights. As you trek into the forest, you find a spot that has an awesome view of the lake and the clear sky above. It's 7 p.m. and you start a fire for some s'mores and get the telescope ready. The only problem is that when the sun begins to set, the moon lights up the sky even brighter. It's surprisingly not as hot as you'd imagine, since it's not direct sunlight, but regardless, it's still pretty hot. Scenario 2. Temperatures will surely rise either way. That means snow will melt away faster than you can go, What's going on? The snow on the mountains will be the first to melt, followed by the polar caps. With so much heat, the sea levels will rise and take small remote islands scattered across the ocean underwater. Coastal towns will go down and everyone will live closer inward. This will likely cause a chain reaction in the world economy. There will be no more winters, which means no more winter activities like skiing, snowboarding, or snow fights. Animals and plants all around the world will be affected. The world will turn into a large desert. Water will get scarce over the years, but people will find a way to preserve it. Scenario 3. You're sitting behind your desk, bored. You're losing business. People aren't buying as many sunglasses as you thought. But when the moon suddenly becomes brighter than the sun, and everyone needs to wear those glasses 24/7 when heading outside, you can't keep up with the demand for sunglasses, so you hire more people and grow your business. You eventually become the best sunglasses business in the country. They don't recommend looking up at the sky at any point of the day or night. Cities are covered with large visors to reduce the brightness every day. Sunglasses will come in different sizes and shapes for different times of the day. Some will be like goggles strapped around your head, while others will be like large helmets. Scenario 4. The moon's atmosphere is so thin that it can't contain anything in it. Just like over deserts on Earth, there are no clouds to bring some rain, which is why it's always hot or cold. Yeah, the biggest desert in the world is the whole continent of Antarctica, which is a cold, barren desert, contrary to what people think of the Sahara Desert. So if you still want to land on the moon, you better think twice now. People who are working at the International Space Station will have to find a new office. The moon will be too bright to bear, considering how close they are. If the moon is just brighter than the sun without the heat part, then the space station will only require adjustments to keep the light out. The reason why we see the moon in various shapes is because of its position in relation to the sun. The moon doesn't rotate, unlike Earth. It's kinda glued to us and is always showing the same side. So, depending on the moon's position during the month, we'll have a super bright night during the full moon, and relatively shiny nights during the rest of the month. Scenario 5. If the moon became brighter than the sun, it would produce more heat than the sun and probably become larger. Gravity on Earth would change significantly because of the moon's new size. The whole orbit structure would change and affect the celestial objects floating in space. Planets would soon begin to orbit around the moon, Earth might move further away from the sun. If that happened, then everything would have to readjust to the radical changes in gravity. Weak gravity means buildings wouldn't have a solid foundation to sit on and would eventually collapse. Bridges and large monuments would also fail to hold up. People wouldn't be able to walk properly and would do it in a funny way. Scenario 6. In many of these scenarios, I mentioned how the moon would be brighter than the object emitting light, but in this case, the sun would have to come from the moon, reflecting from the sun, which means that the sun would have to be twice as bright as it is now. If the sun got 100 times bigger, it would shoot out more rays, which can be damaging and throw off a lot of radiation, harmful to every living thing on Earth. The gravitational pull of the sun might attract more planets to orbit around it and cause other objects in space to join the orbit. The planets would be partying in our galaxy club, and we might be thrown off our orbit course. Of course, this would pose a bigger risk to everything on Earth as things would get hotter and drier than before. Scenario 7. If we're talking about the moon getting brighter, we can also assume it would get closer to Earth than it is now. The brightness won't be the problem here, as gravity will cause major changes on Earth. But every day, 24/7 will be high tide. It will be so extreme that there will be constant floods in every coastal town. All islands will be submerged, which will increase the population of inland cities. Marine life will be having the time of its life when water overtakes the land. Boats will have to be re-engineered for new conditions as well as submarines. Air travel will be the priority, but large cruise ships will look futuristic and have an extra build to sustain the harsh waves. Nighttime will be pretty bright on regular days. It will raise the global temperature, which will melt down the snow, causing the sea levels to increase even more. Comets and other celestial objects will be drawn to a closer gravitational pull, so we will always have to look up whenever we go outside. But no worries, the moon is still up there as it is for a very long time. The Earth and the moon's relationship is complicated. Luckily, we only have one natural satellite. Other planets in our solar system have multiple moons revolving around them. Some are so huge that they're the size of Earth. Imagine several of those affecting our home, but that's a topic for a completely different story. Now, what would Earth look like if it was the only planet in the solar system? Or, what would happen to our planet if the moon went missing? Or, what if dinosaurs had never gone extinct? We've all heard the story. Over 66 million years ago, a big asteroid hit Earth. Almost 75% of creatures that roamed the planet at the time were wiped out in mass extinction. Among them, dinosaurs. Tyrannosaurus, Triceratops, Velociraptor, all gone. But because of that, we're all alive. According to science, the human race was developing more safely without these gigantic creatures hunting us. But what if that asteroid had crashed to the ground a few miles away from the place where it fell? What would the world be like today? Imagine walking down the street to your local supermarket and coming across a truck-sized T-Rex. Could that ever happen in this alternate universe we're talking about? Well, dinosaurs would have had to survive a lot more than an asteroid to be living nowadays. About 55 million years ago, the temperatures on the planet rose. The climate became 14 degrees Fahrenheit hotter than it is today. Rainforests flourished, and vegetation was abundant. In this scenario, herbivore dinosaurs would have likely thrived. But they would have started to look a bit different. Plants started growing during that time period were not very rich in nutrients. This means that dinosaurs would have probably shrunk in size, not having the necessary energy to grow all the way to their full size. Then, about 34 million years ago, South America and Antarctica split, which resulted in a cooler and drier climate. During this period, long-legged dinosaurs would have been the ones to survive. At that time, animals had to travel long distances to hunt, since seasons started to affect the availability of food and water. Compared to the mammals of that period, dinosaurs would have had significant advantages, like having more teeth or better eyesight. And speaking of mammals, some of them probably would have never evolved. That would have become dinosaurs' breakfast first. By the way, did you know that some dinosaurs live among us today? Think pigeons, or birds in general. They've all evolved from dinosaurs. Now, I bet you've heard once or twice that we use 10% of our brains. If this was true, what would happen if you used 100% of our brain? Would you be able to compose a symphony? Would you become a tech genius and create a multi-million-dollar company overnight? Let's start with the facts. We don't only use 10% of our brain. This notion became highly popularized by movies, but it's not very accurate. The truth is, the largest portion of your brain is active at all times. But not all parts are working simultaneously. The exact percentage varies from person to person. Now, neurologists say you wouldn't be using 100% of your brain's capacity at once. Your body simply wouldn't have enough energy for that, which means you'd be hungry all the time. Imagine the number of calories you need to consume for that to work. You would also be limited by your body's basic needs: breathing, digesting food, and circulating blood. So if you did use all of the capacity of your brain, you'd be tired all the time. It'd be worse than running a marathon without any preparation. The brain would need all the blood you'd have, which would mean less oxygen for your lungs. Different organs would begin to shut down one by one. In a nutshell, it'd be terrible for your health. By the way, some researchers have estimated that more than 60% of the brain is composed of something that is called neural dark matter. In other words, this dark matter consists of neurons that have no apparent purpose or simply don't respond to common stimuli. Marathons are some of the greatest feats of strength and endurance in the world, but what would happen to your body if you decided to run a marathon without any training? The statistics are overwhelming. Nearly 50% of participants drop out of the race before crossing the finish line. A regular marathon is 26 miles long, and if you're not used to physical activity, it's a great challenge. You'd probably be able to run the first mile without any serious problems, but breathing loudly and heavily through your mouth. By the third mile, your body temperature would skyrocket, and you'd feel as if you have a mild fever. You'd most likely give up here, but if you decided to keep going, you'd have to trick your mind and body into running another 23 miles. By the 20th mile, you'd hit what is known as the wall. Your body would have burned all your reserves of glucose, and you'd get extremely tired. Even experienced runners often go through this stage. By the end of the marathon, you'd be promising yourself to never do this again. You'd leave the race with at least a few cramps and many food cravings. Now picture this. It's a clear, beautiful night. There are no clouds, and you can see two of the brightest planets in Earth's sky blinking up there. Those are Mars and Venus. Now, have you ever imagined what would happen if Earth was the only planet in the solar system? If the other planets never existed, things would be really different for our Earth. The planets in the solar system work together, keeping one another in certain place with their gravitational pull. Now, if Mercury or Venus ceased to exist, Earth would drift closer to the Sun. Our atmospheric temperature would become similar to that on the surface of Mercury, 800 degrees Fahrenheit. This would make life on Earth impossible, but if Jupiter or Saturn disappeared, Earth would most likely drift further away from the Sun, and its temperature would drop to below -200 degrees Fahrenheit. If life managed to survive in such circumstances, it would probably be aquatic. The position of Earth in the solar system not only affects all kinds of life forms, but it also dictates seasons, the length of days, and how long one year lasts. Now, when we say no other planets, we mean no moons either. So, what would happen if one fine day the moon just disappeared? That would have catastrophic consequences. The moon has the largest influence on Earth's tides. In a moonless universe, tides would shrink by about 75%. This would greatly affect crabs, mussels, and sea snails that live in tidal zones. This would consequently disrupt the diet of larger animals. Eventually, it would affect entire coastal ecosystems. Earth's weather would change. Tides and tidal currents help mix cold Arctic water with warmer water from the tropics, stabilizing the climate worldwide. Weather forecasting would become almost impossible, and the average difference between the hottest and coldest places on Earth would become extreme. The absence of the moon would also influence Earth's tilt. Right now, Earth tilts on its axis at 23.5 degrees, mostly due to the moon's gravity. With no moon around, Earth's axis would wobble between 10 to 45 degrees. Scientists believe that even a slight difference in Earth's tilt can cause huge changes, such as an ice age. Other than this, a moonless sky would upend the lives of many nocturnal animals. Moths have evolved to navigate using the light of the moon and stars. Newborn baby turtles use the moon's light to find their way to the ocean. Different animals rely on both darkness and a small amount of moonlight to hunt effectively. Now, how about we travel far back in time and imagine what would happen if you lived in ancient Egypt? This civilization lasted for over 3,000 years. Ancient Egyptians were responsible for building some of the world's most recognizable symbols, the Great Pyramids at Giza. If you'd lived in ancient Egypt, you'd have witnessed a time of enormous scientific and mathematical breakthroughs. Ancient Egyptians organized themselves in strict social structures, so you'd probably have to fit into one of them. You'd have either been born a laborer, a farmer, or a specialist, which was either a soldier, a sailor, or a teacher, or you'd have been part of the Egyptian elite. If you had been a farmer, you'd probably live in a house made of mud bricks. You'd have had a stone oven and kept your food stored in a pit in the ground. You'd have spent your days tending to crop fields by the Nile River, or taking care of cattle and ducks. On tax days, you'd have packed up some of your harvest and brought it to the temple as payment for the usage of land. If you'd been a member of the elite, you'd have spent most of your days in banquets. You would have adorned yourself in gold and semi-precious stones, displaying all your wealth. If you had lived in ancient Egypt, maybe you would have been one of those who invented tables. Yep, before the Egyptians, there was no such thing as a table. This invention appeared as a way to keep food off the ground. The Moon. A beautiful, natural satellite with some mysterious dark splotches. We always see only one side of it, so we're used to this image. It's hard to imagine the moon looking any other way. But it used to be different. Oh ho ho, it used to be so different. Picture this, a huge incandescent satellite in the sky that is causing constant tsunamis. I suggest we go very far into the past to see what the moon was like many, many years ago. The moon formed around 4.5 billion years ago. At that time, our green-blue planet was still a red-hot, insanely unstable piece of rock flying in space. We didn't have the moon yet, and a day on our planet only lasted 6 hours, which meant only 3 hours of daylight. Volcanoes erupted all over the place, releasing poisonous gas into the air, and a bunch of meteorites regularly crashed into the planet. At the same time, 4.5 billion years ago, the so-called Big Splash occurred, or, as scientists call it, the Giant Impact Hypothesis. It claims that once an object the size of Mars crashed into Earth. Mars is about 2 times as small as our planet, so the blow wasn't too bad, but it was quite catastrophic. This powerful impact tore off part of the outer layers of that Mars-sized object and Earth. The very core of this space body merged with Earth's own dense core, and a huge number of fragments of Earth flew into outer space. So, this was the beginning of our moon, or, saying in a scientific way, the process of differentiation has begun. This is the process all planetary bodies go through at the beginning of their lives. Since the impact was very hot, its heat carried away most of the gases and liquids from the broken pieces of Earth. Only a relatively dry stone surface remained. So yeah, there is water and gases on the moon, but in very small quantities. The gravity of our planet was strong enough to make all these hot stone fragments stay in its orbit, and they gradually began to stick together. The chemicals they contained were distributed in layers. Iron, which was heavier, sank deeper inside, and lighter elements formed the surface. In a short time, 100 years or less, the ring of steam, dust, and molten rock fused together. The largest clusters with the strongest gravity attracted more and more particles, gradually forming the moon. It looked like a red-hot bubble ball. Sadly, the nucleus of this newborn moon turned out to be very small. It lacked iron and other heavy elements to form into something substantial, like a planet. The oldest rocks of the moon probably formed in the ocean of magma. And when the moon gradually cooled down, it turned out to be a white, clean, and perfectly even ball. But it was still completely different from what we have now. To begin with, immediately after its birth, the satellite was located at a distance of only 13,500 miles away from Earth. This is 15 times closer than it is now, around 238,000 miles. It's scary to imagine how huge and bright the moon looked in the sky at that moment. The view was probably both beautiful and terrifying. And, of course, such proximity caused incredibly huge waves on Earth. The planet experienced regular tsunamis. Also, at that time, the moon was spinning very fast, and it wasn't turned to Earth with only one side. But, in general, Earth and the moon had a positive impact on each other. For example, it was the moon that made our day last 24 hours. Now, Earth's axis is mostly tilted 23.5 degrees from the plane of its orbit around the Sun. Without the moon, Earth rotated rapidly, but thanks to the satellite, the planet's tilt stabilized, which led to a wide and pleasant variety of climates on Earth. To be fair, the gravity of our planet also helped the moon. Thanks to it, the moon began to rotate more and more slowly while gradually moving away from us. Over the years, its orbit has moved far away from our planet. At the same time, the moon became tidally locked to Earth. This means that its rotation period coincides with its orbital period. Or, in other words, the moon moves around itself as fast as it moves around the Earth. That's why the moon always faces our planet with only one side. When the moon moved away, tides on Earth became calmer. Now, water could flow to the most remote corners of our planet. It was then that life appeared on Earth. But back to the evolution of the moon itself. What was happening on its surface after its formation? The next stages of the moon's development were childhood and adolescence. And as is usually the case at this stage, this period was insane. No wonder. About 4 billion years ago, the solar system was going crazy. During the first 600 million years of the moon's existence, large asteroids and comets constantly collided with it. Now, they were bothering not only our Earth, but also its satellite. These impacts were the most powerful in the history of the moon. They left many large craters, which were later filled with dark rock. So, Earth wasn't enough for you, huh, space? Once, a dwarf planet crashed into the moon. It was about the size of Ceres, the largest object in the asteroid belt between Mars and Jupiter. This explosion formed the SPA basin and also forever changed the appearance of the moon. Can you see that dark spot on the far side of the moon? Right there in this very south? This spot is called the South Pole Aitken Basin. Its diameter is about 1,600 miles. And yes, it was formed by the impact I've mentioned, about 4.3 billion years ago. This planet brought with it a bunch of complex and strange chemical compounds that scientists are now finding all over the far surface of the moon. These compounds began to emit a lot of heat, melted part of the lunar mantle, and, oops, accidentally woke up volcanoes. The volcanoes began to erupt furiously. A huge amount of magma was distributed over the surface of the moon. Many years later, it cooled down, leaving behind those famous dark splotches that we're so used to. They're called the lunar maria. There are much fewer craters there than on the lunar highlands. But for the last billion years, the moon has been geologically inactive, except for occasional collisions with meteorites. In general, the appearance of the moon changed forever as a result of these events, and, battered and tired, it entered adulthood. But even then, it couldn't get any peace. A bunch of meteorites decided to bother it again. Honestly, it wasn't that bad. There were many collisions, but all of them were quite small. They just left a bunch of craters and pits on the moon, and maybe damaged its mantle a little. Some of the collisions deepened already existing large craters. The moon's crust was getting thinner and thinner over the years because of all the chaos going on. And now we call this upper part of the lunar crust covered with craters the lunar highlands. All those white and bright areas of the moon, the highlands. But in the end, the universe finally calmed down, for now at least, and the moon began to look the way it does today. There are still many things we don't know about Earth's natural satellite. There are moments in its history that scientists still can't accurately explain, but they're continuing to study our beautiful satellite. The data about the moon is useful to people not only for its own sake. It gives us a more complete picture of both the history of our solar system and space as a whole. So, let's hope that one day we'll be able to find out everything there is to know about the moon.